these before, where we talk about that meaning a union and that meaning intersection.
No.
Did you do that?
Oh yeah, I think so.
Yeah.
No, we did that in probability.
In probability.
Oh yeah, so it is the same.
Yeah.
We use the same symbols when you're going to have two bits of a domain that are, I guess, not continuous. There's a gap in the middle. So, so for this one here, we know that the values of x can be anything except 0. It can be a little bit more than 0, 0.01. It could be a little less than 0, negative 0.01, or even closer than that. And it can go all the way to the infinity negative and all the way to the positive negative, positive infinity, I should say. But it's just that little gap in the middle that it cannot exist at, because we cannot have 1 over 0. And so we use these symbols here, union and intersection. So we'll say that at one level, it's negative infinity all the way up to 0, but not including 0. Remember, that's what the curved bracket means, not including. And that is a union with, put together with, again, from 0 all the way to positive infinity. And that's our domain. Having seen that, how would I write, therefore, the range?
Wait, the bracket next to the 0, wouldn't that be that squarish?
The square means it can be included.
Oh.
So is 0 part of the domain or not? No, it just means anything above 0 in this case, or that one then, anything below 0. Yep. So I write the range then. What can it be? What can my function be? If I think about when x is massively positive, what does that get close to, that fraction? 1 over billions and billions.
0.
It's really close to 0, but can it ever equal 0?
No.
No, it can't. So once again, we're actually going to have exactly the same notation. Because we can have anything that's really, really, really tiny when it's 1 over a huge number, or when it's 1 over a tiny number, that's function value is really big. 1 divided by 0.00001 is massive. So, once again, negative infinity, comma 0, united with 0, comma infinity. Does that make sense? Yep.
So, would you not use the other one? The intersection?
Oh, we don't use that in this.
Okay.
We're never going to have an overlap. If there's an overlap, you just don't need to do that. That comes out in other things, like in probability. Alright, I've kind of gone so far here because I've...
Why can't you just get rid of the u? Because it'd still be the same thing, wouldn't it?
Yeah, it's, I mean, I guess like you can kind of see that it would be, but this is the way we write it.
Okay.
Alright, I've got this one here. Who can tell me, what can x be? What can x be? Or maybe it's easier to say, what can x not be? That might be an easy way to start. What can x not be?
0.
Can't be 0. Anything else?
No, it can be 0.
You guys
0.
0 minus 1. Can you take the square root of negative 1?
No. Yeah.
Not yet.
Oh, well.
Extension 2. Oh. And so 0 can't be there, but then also other things. You cannot have a half. What's a half squared? It's a quarter. A quarter minus 1 is also negative. What's 0.9 squared is 0.81. Take away 1 is negative. Basically anything up to what?
1.
1, isn't it? But can it be 1 in this case?
Yeah.
Yes, it can be 1, can't it? Because we can have 1 squared, 1. Take away 1, 0. Can we take the square root of 0? Yes, we can. Okay? And so our domain here, our domain is similar. I'll talk you a positive there for a moment. What about the negative side? Well, not higher than 1, because we're talking negative. Less than negative 1. Okay? Because it's squared, there's a symmetry to it, isn't there? Everything greater than 1, including 1. Everything less than negative 1. Because again, once we square negative 1, we get positive 1, and then that becomes 0 inside there, and we can do anything less than negative 1, we'll end up with a number greater than positive 1. Okay? And so, negative infinity to negative 1. Square bracket or rounded bracket?
Square.
Why?
Because it includes.
Includes, that's right. So square bracket is included, united with, and again, we're going to just mirror on this side. Square bracket, comma, infinity. Okay? What about the range though? Let's think about this. Let's start this in. When x is a massive negative number, what is x squared?
Negative.
Massive positive. Okay, take away 1, still pretty massive positive. Square root of that, still pretty massive positive. We don't, we just talk about that aspect of infinity. All the way down to negative 1. If it's negative 1 squared, take away 1, 0, squared, square root of that, 0. Okay? If you're going to do the same the other end, and so if we have a positive 1, that's 0, same there. Positive infinity squared is infinity, take away 1, square root, still infinity. So it's symmetrical. Can we see that on both sides? And so in this case here, we only need to talk about just 1, 0, like that, just 1 bit to it. We don't need 2 bits uniting, okay? Because at both ends, these values give us the same. Yeah.